Boom! What up, math nerds and mathletes? Coach Murphy here. It's time to get on that math grind. It's time to exercise that math muscle. All right, let's get mentally jacked. All right, let's get huge on math. What about that? Get on that math grind. I'm pumped. I am pumped about it. You should be pumped too, because today we are going to talk about factoring trinomials. I know, it's exciting. And we're going to factor trinomials in the form of x squared plus bx plus c. So there's no a, there's no number in front of the x squared, right? So we are going to get on that grind. We are going to dominate factoring trinomials, all right? Stick with me. Get ready. It's going to be intense, and it's going to be awesome. So once again, we're talking about factoring trinomials, right? That's what we're talking about. Okay, and we're factoring trinomials, like I said, in the form of x squared plus bx plus c, right? So we want to break it down. Like, factoring, as we know, is just the opposite of distributing. As a lot of you guys did, FOIL, first, outer, inner, last. I just like calling it distributing. Passing out candy on Halloween. This is the opposite, right? We're breaking it back down. Okay? So when we factor, I like to use this X method here. When we factor, I want to find two numbers that add up to B and multiply to C. Okay? So, if I'm looking for two numbers that add up to B and multiply to C, right? We can go through several numbers. Some people can just look and identify them, right? Some people have that skill. Some people don't. Some people it takes more time, whatever, right? So for example, let's say we had x squared plus 7x plus 12, right? I'm looking for two numbers that when added together give me positive 7 and when multiplied together give me positive 12, right? So we can sit here and we can go through all our numbers. We can go, let's see, 1 times 12 is 12, but does it add to 7? No. Okay. 6 times 2, all right, that gives me 12. But if I add them, that gives me 6 plus 2 is 8, right? What about 3 and 4? 3 times 4 is 12. 3 plus 4 is 7. Perfect. So positive 3, positive 4, right? And then we write it as x plus 3 times x plus 4, right? Pretty straightforward. Nothing too crazy. Nothing you can't do. All right. Let's look at some more examples, okay? Let's look at this guy right here, right? So, I don't know. I've always found drawing this x makes it a little easier. So I got positive 9, positive 20, right? I want to find two numbers that add to positive 9 and multiply to positive 20, right? We can go through. We start going through. We start with 1, 2. There's not a 3. What about 4? 4 times 5 gives me 20, right? 4 plus 5 gives me 9, right? So I go positive 4, positive 5, which leaves me with n plus 4 times n plus 5, right? Piece of cake. Okay? Let's scroll on down. Let's look at this example right here. Okay? Now we need to find two numbers that add up to positive 3 and negative 18. Right? So, we got to be careful with this because we're going to have some positive and negative numbers in there, right? Now I know, and you know, that 6 times 3 equals 18, right? 6 times 3. But which one's positive, which one's negative? Because if I make 3 negative and 6 positive, I'm still going to get negative 18. If I make 6 negative and 3 positive, or 3 positive, or 3 negative and 6 positive, they're both going to give me negative 18, right? But if this right here is positive, that means our bigger number has to be positive. So positive 6, negative 3. So we have n plus 6 times n minus 3. Okay? It's important to remember that. Okay? Let's go ahead and take a look at another practice problem. It's always get practice, man. Practice doesn't make perfect. Perfect practice makes perfect. You practice like garbage, you're going to perform like garbage. Practice like an all-star, going to be an all-star, right? So let's go ahead and take a look at this one right here. Okay, we need to find two numbers that when added together give me negative 12 and when multiplied together give me negative 64. Okay, I'm going to save you the suspense. Okay, 16 and 4. But which one's positive and which one's negative? Glad you asked. If this number up here, the number that we have to add together, is negative, then our larger number is, yes, you guessed it, negative. Okay, so we have k minus 16 times k plus 4. Right? And you guys are on fire right now. Straight fire. Okay, let's take a look at another one. Just for fun. Just for fun. Okay, let's look at this one right here, number 13. Lucky number 13. Okay? Now, we have negative 11, right? And positive 24. So we got to figure out, okay, what two numbers? Well, let's look here. If that's a negative, right, and that is a positive, right, we're looking like we might have both numbers being negative. So what two numbers add up to 11 and multiply to 24? Well, we have a good bit of those. I'll save the suspense. 8 and 3. Right? But they can't be positive, right? Because a positive plus a positive is a positive number, right? So they must both be negative, leaving us with x minus 8 and x minus 3. Okay? Now let's scroll on down. What if there is a number in front here? What do we do? Do we freak out? Do we panic? Do we say, impossible, can't do it? Coach Murphy, when am I ever going to use this? This is stupid. I don't want to do this anymore. I quit. Absolutely not. You cannot jump off the factoring train just when it gets hard. No, choo-choo. Right? You can't stop it. You cannot stop the grind. Okay? First thing we do, I told you guys in a video a couple days ago, first thing we do when we factor is we look for the GCF, greatest common factor. Boom! Mind blown. What do each one of these coefficients have in common? That's right, the number 4. Divide it on out, man. Get crazy with it. Okay, we put that 4 outside here. We're left with k squared, right, plus 3k plus 2. Now we can do the factoring that we've been doing, right? We got to look for a number that adds to positive 3 and multiplies to positive 2. All right, I'm going to save you guys a suspense once again. It's 2 and 1. Okay, positive 2 and positive 1. So we drop this 4 on down, right? We can't forget about it, even though he's on the outside. Right there, plus 2, k plus 1. Okay? So we always look for the greatest common factor, right? What about if we get here, we're like, whoa, that says a cubed, not a squared. Time out. You didn't teach us that. You're terrible at teaching. Go back to Ohio. Go back to North Carolina. Go back wherever you're from. Go back there because you're terrible. No. Greatest common factor. What do each one of these have in common? Well, first, I know they have a 3 in common. So I can take 3 out of each of these. But what else do they have in common? They have an a variable in common. So just take that a out. It's okay. You're not getting rid of it. You're just taking it out. So I put the 3a out here. That leaves me with a squared plus 10a plus 21. Right? Now we can factor that. Okay, we want a number that adds to positive 10 and multiplies to positive 21. Okay? Being a huge fan of multiples of 7, I can tell you that it is 7 and 3. Since that's positive and that's positive, they're both positive. It's good to be on a positive note, right? Got to keep that 3a. Got to keep them in the family. Put them there. We get a plus 7 times a plus 3. Right? Boom. There we go. Let's look at one more example, because you're going to get one of these and you're going to go, whoa, this has got 2 variables in it. This is not math. This is nonsense. When do they start putting letters in math? Why? Why do we have letters in there? Doesn't make any sense. Save that for English. Hey, I don't make the rules, right? I just enforce them, right? Like Judge Dredd said, I'm not above the law, I am the law, right? Okay, so what can I pull out of all of these? Well, first we always look for the coefficient. It's a 5, it's a 15, it's a 0. Remember, if the number ends in 5 or 0, it's a multiple of 5. So I can pull 5 out of both of these. All right, do they have a variable in common? Well, that has an x, that has an x, that doesn't. That has a y, that has a y, that has a y. Boom. Pull out the y. Right? Put them out here, put them in timeout, whatever you got to do. Right? Leaving us with x squared minus 3x minus 28. Right? Make our little x. What adds to negative 3 and multiplies to negative 28? Once again, being a huge fan of the number 7 and the multiples of 7, and 28 being probably the greatest number ever created, I know that it is 7 times 4. Right? Seeing how that number is smaller, right? That number is a negative number. I know that the bigger number must be negative, the smaller number must be positive. Right? Bring out this 5y, because he's still part of the family even though he's on the outside. We get x minus 7 times x plus 4. Boom. There you go. Now, that's it. Right? That wasn't so bad. Right? That was a piece of cake. All right? Nothing too crazy, nothing too hard. Just a little factoring. You know how to do it. Have faith in yourself, right? I know it was exhausting, right? We dominated that math workout. Right? So go fuel, go rehydrate, get ready for the next round. All right? I'm out.